All right, so last lesson we talked about solving absolute value equations. Okay, now we're going to take it and tie it into what we've been solving before in this chapter with inequalities. Okay, so today we're going to talk about solving absolute value inequalities. So what we are going to do is we're going to relate these two different types of problems to compound inequalities that we did a couple sections ago. So if you have the absolute value of ax plus b is less than c, or less than or equal to, okay, either one would be fine. Okay, this actually turns into an and problem. Okay, so how you're going to set it up so you can solve it like we did an and problem before, you're going to do negative c, whichever inequality sign we're using, so we'll just use less than for now. And then ax plus b goes in the middle, and then less than c. Okay, so we've taken an absolute value inequality and created a compound inequality that you then can solve since we've done it before. Okay, so if less than is an and problem, greater than is going to be an or problem. Okay, so you got absolute value of ax plus b greater than or equal to c. So what we're going to do is we're going to do ax plus b is less than negative c, or ax plus b is greater than c. So basically, leave what's in the absolute values alone. We're going to flip the sign, make the c negative, or we're just going to take away the absolute value signs and create our or problem. Okay, so make sure we've got these things written down in our notes, because that will be helpful when we get to actually solving these problems. All right, so we've got absolute value of x plus 1 is greater than 1. Okay, so the first thing I want you to decide is this an and problem? Is this an or problem? So based off of what we wrote on the last slide, this is an or problem. So I'm going to set it up x plus 2 less than negative 1, or x plus 2 is greater than 1. So then we solve our or problem separately. Subtract 2 from both sides. Yeah, x is less than negative 3. Subtract 2 over here. X is greater than negative 1. Okay, so my answer, x less than negative 3 or x greater than negative 1. And then since it's an inequality sign, we have to go back to graphing. On the last section, we didn't have to graph. So we've got 0, got negative 1, negative 3. Open circles on both of them. And then since it's an or problem, our arrows face away from each other. Okay. Moving on to the next one. I've got absolute value of 2w minus 1 is less than or equal to 11. Okay, so think about, is this an and problem? Is this an or problem? Okay, so this actually ends up being an and problem. So we set it up, negative 11 less than or equal to 2w minus 1 less than or equal to 11. So then remember, we draw our lines down from both of our inequality signs. So I'm going to add one in the middle, add one on the left, add one on the right. So negative 11 plus 1 is negative 10. 2w in the middle, 11 plus 1 is 12. Divide by 2. So I get negative 5. I didn't divide by a negative, so I get to keep my signs the way they are. So less than or equal to w, less than or equal to 6. And that looks mathematically correct. The smaller number came first. So you got 0, got negative 5, we've got 6. Closed circle on both of them. And pointing towards each other because we are an and problem. All right, so just like with solving absolute or solving inequalities before, or solving absolute value equations, Okay, we always want to get our absolute value by itself first. Okay, so if you look at this problem, I've got 5 absolute value of 1/2 r plus 3 is greater than 5. Okay, so the first thing I want to do is get my absolute value by itself. So we're going to divide by 5. So I'm going to have absolute value 1/2 r plus 3 is greater than 1. Now my absolute value is by itself, so then I want to decide, is it an and problem or an or problem? So this one is an or problem. It's all based off of your inequality sign up there. So I'm going to use it here a little bit. 1/2 r plus 3 is less than -1, or 1/2 r plus 3 is greater than 1. So then we solve them separately. So subtract 3. 1/2 r is less than -4. Divide by 1/2. Again, be careful how you type this into your calculator. So you got r is less than -8. So subtract 3 over here. 1/2 r is greater than -2. Divide by 1/2. R is greater than -4. So answer is r is less than -8, or r is greater than -4. And then we'll graph it. So you got 0, then we've got -4 and -8. Open circles on both of them. And since it's an or problem, our arrows point away from each other. All right, we've got one more. So again, just like before, we want to get our absolute value by itself. Okay, so I'm going to add 8 to both sides. So 3 absolute value of 5m minus 6 is less than 21. And then divide by 3. So absolute value of 5m minus 6 is less than 7. Now we can write our equation. Okay, so determine if it's an and or an or problem. Since it's a less than sign, this is an and problem. So we're going to set it up. -7 less than 5m minus 6 less than 7. So we draw our lines down. I'm going to add 6 to both sides. Actually, all 3 sides. -7 plus 6 is -1. Still have the 5m in the middle. 7 plus 6 is 13. Divide everything by 5. -1 divided by 5 is not a whole number, so I'm just going to leave it as -1/5. Less than m, less than 13 over 5 doesn't simplify either, so I'm just going to leave it as 13 over 5. Okay, if you wanted to write 13 over 5 as 2 3/5, that's fine as well. Okay, make an improper fraction a mixed fraction. Either way works. So then when we graph it, so I got 0, got -1/5, then I've got my 13/5. Open circle on both of them, and they point towards each other because we're dealing with an and problem. Okay, so that is solving absolute value inequalities. We will do some practice in class with these so you get more practice because these are a little bit more complicated.